Assalamualaikum warahmatullahi wabarakatuh. We are from class 5C and from group 1 we present about the factors affecting water scarcity on renewable fresh water in Middle East country, which are Jordan, Yemen, Iraq, Lebanon and Syria. And these are my team members.
Hi, my name is Nurfahana Chorabik Yasbullah, matric number 2022-467796. I will explain about the research background and the scope of study. This study explores renewable freshwater accessibility in Jordan, Yemen, Iraq, Lebanon and Syria, highlighting the severe water scarcity challenges they face. Factors like climate change, population growth, and geopolitical conflict has intensified these issues, making the Middle East region one of the most water scarce in the world. For example, Jordan freshwater availability has dropped dramatically, placing it the most water-stressed nation globally.
Next is the problem statement. As you can see from the slide, the graph illustrates the alarming decline in renewable freshwater resources per capita over the years. Countries like Jordan, Yemen, Syria, Iraq, and Lebanon are experiencing extreme reduction in water availability, signaling a critical crisis. And according to McConnell and Hustra, the primary causes of this crisis include climate change-induced drought, rapid population growth, inefficiency water resource management, and ongoing political instability. UNICEF 2021 said these factors have significantly reduced the availability of renewable freshwater, increased competition over existing resources, and contributed to regional conflicts and humanitarian crises. Next is the problem statement. As you can see from the slide, the graph illustrates the alarming decline in renewable freshwater resources per capita over the years. Countries like Jordan, Yemen, Syria, Iraq, and Lebanon are experiencing extreme reduction in water availability, signaling a critical crisis. And according to McConnell and Hostra, the primary causes of this crisis include climate change-induced drought, rapid population growth, inefficiency water resource management, and ongoing political instability. UNICEF 2001 said these factors have significantly reduced the availability of renewable freshwater, increased competition over existing resources, and contribute to regional conflicts and humanitarian crises. Water scarcity has reached extreme levels, leading to severe socio-economic and environmental consequences. Millions of people are being affected with access to clean water becoming extremely difficult. Contaminated water source pose serious health risks, further worsening living conditions, said Lee Monday 2024. Moreover, Abdel and Quarry 2018 said the depletion of water supplies without sustainable intervention could result in increased migration, heightened social unrest, and long-term economic downturns. This highlights the urgency of addressing water scarcity. Water scarcity is not just an environmental issue, it is a humanitarian and geopolitical crisis. Effective water management and strategic policy making are crucial in ensuring sustainable freshwater availability for future generations.
This study explores the key factors driving water scarcity and the impact on renewable freshwater resources in Jordan, Yemen, Iraq, Lebanon, and Syria. It examined the 5 major contributors such as rising temperature, population growth, agricultural water withdrawal, irrigated land, and overall water usage. By analyzing data from 2000 to 2023, this study aims to identify long-term trends and variation in water scarcity across these countries, providing valuable insights into the sustainability of freshwater resources in the region. Hence, the specific hypothesis for this study is HO. There is no significant relationship between all independent variables and renewable freshwater in Jordan, Yemen, Iraq, Lebanon, and Syria. Meanwhile, H1, at least one independent variable has a relationship with the renewable freshwater in Jordan, Yemen, Iraq,
Chapter
Lebanon.
2 Literature Review. I will explain the theory of study where the management of fresh water is based on its natural renewal through the hydrological cycle, and it involves evaporation, condensation, precipitation, and runoff essential for ecosystems and human life. There are 3 opinions that I would like to share where from Bernhard, early contributor to to understanding the continuous movement of water and its interconnectedness. From John Wesley Powell, he studied the river systems and water management, advocating for sustainable practices like rainwater harvesting and groundwater recharge. For Peter Gleick, he explored climate change effects on water resources, showing how consumer patterns influence water availability. And the main idea is to conscious management and sustainable use of fresh water ensure long-term availability for ecosystems and human activities. Next is the review of literature for renewable fresh water. The renewable fresh water includes rivers, lakes, aquifers, and wetlands which can naturally replenish, and it is essential for the human survival and agriculture and ecosystem. Freshwater supplies are under pressure due to the population growth, urbanization, climate change, and population. For example, in Florida, where they are rich in freshwater but faces over-extraction and droughts, and they need balanced management for agriculture, urban growth, and sustainability. For water scarcity, the Earth has 4.16 billion of kilometer square of water, but only 1% of it is accessible. The population growth worsens scarcity and water quality. Next one is sustainability concerns, where the global crises include supply-demand mismatches, lack of clean water, and ecosystem degradation. Traditional water management is outdated due to the climate variability, and it needs for flexibility, adaptive strategies in water resource management. The next one is the review of literature for population growth, where fresh water availability are less than 1% of Earth's water is usable, raising concerns about scarcity. And the impact of population growth increases the human demands, worsen water shortages and quality, and expansion of water supply capacity and rising use of washing machines contribute to demand. The water conflicts are the water scarcity fuels territorial disputes and military tensions, and sub-Saharan Africa faces severe access issues with nearly 2 billion people in high water stress regions. And economic and social impact, 80% of water use is for agriculture, making it highly vulnerable to scarcity, and water shortages hinder economic growth and social stability. For sustainable water management, rising temperatures and population growth will intensify water demand. Current governance strategies need revision to ensure future water security. Global connections are the water is not just only local issue but also agriculture and trade link water consumption to global markets. For the third review of literature of agricultural water withdrawals, the largest consumers of fresh water is the Middle East countries due to agricultural accounts for over 80% of water withdrawals in Middle East countries. The next one is the inefficiencies in water use, where flood irrigation causes excessive water loss through evaporation and runoff. And 60% of the irrigation water wasted due to poor infrastructure and inefficient practices. Next is the groundwater over-extraction, where it leads to aquifer depletion, lower water tables, and increased salinity, reducing land productivity. And crop selection for climate change, water-intensive crops such as wheat, rice in arid conditions worsen the water scarcity. Unpredictable rainfall patterns due to climate change further strain the agriculture, and the sustainable solution is to promote precision irrigation, implement regulations for water-efficient farming, encourage drought-resistant crops and water reuse strategies, and foster collaboration between governments, farmers, and researchers to ensure water sustainability. For the fourth review of literature is agriculture irrigated land. For the first one is the water scarcity as a global risk, where it is increasing due to population growth, climate change, and inefficient water use. And agriculture is the largest consumer for fresh water. The next one is the regional water challenges, where Middle East and North Africa countries withdraw more than 8 times their renewable water resources. And in Jordan, 53% of total water withdrawals used for irrigation, severe water stress. The next one is irrigation and efficiency issues, where inefficient methods causes flood irrigation and causes high water loss. Modern techniques like drip sprinkler irrigation improve water use efficiency up to 90%. Next one is climate change impact, where rising temperatures and shifting rainfall increase irrigation demand, and it projected 20% increase in irrigation water demand and 10% decline in crop yields by 2080. For the future water and food demand, by 2050, 10 billion people equals to 70% increase in agriculture production needed, and water distribution up to 25 to 40% needed for sustainable use. For the sustainable solutions, efficient irrigation management, drought-resistant crops and smart water policies, and water reallocation from agriculture to high-demand sectors. For the fifth review of literature is water usage, where the first one is global water crisis. It is essential for life, economy, and ecology, but facing severe scarcity. Population growth, climate change, and mismanagement increase the demand. For the sectoral water use, in agriculture, the largest consumer, like Middle East country and North Africa countries, up to 70% of water withdrawals is used and 50% plus lost to inefficiency. And in industry and urban use, the demand for manufacturing and cooling and processing is very high. And for the urban water loss, 80% plus of city populations lack of clean drinking water. The climate change impact alters the precipitation, increase droughts, and reduce freshwater supply. And the Middle East country and North Africa countries face worsening shortages threatening food security. And the solutions for sustainable water use is we need to have efficient irrigation, desalination, water pricing, and trading incentivize conservation, wastewater recycling, increase freshwater supply, and also regulatory frameworks needed to control over extraction.
Assalamualaikum, my name is Nur Ain binti Muhtalib. Next, I will be presenting the theoretical framework for our research. First, we consider population growth. As the population increase, the demand for fresh water also rise. Study by Dolan et al. 2021, Pena Ramos et al. 2021, and Tazanakakis et al. 2020 highlight how population pressure affect freshwater resources, leading to potential water scarcity. Next, rising temperature play a significant role in freshwater availability. Climate change lead to higher evaporation rates, reducing water level in lakes, rivers, and reservoirs. Research by Abbas et al. 2022, Mishra 2023, and Abdul Leva 2024 support this link between rising temperature and freshwater depletion. Another crucial factor is agriculture water withdrawal. Agriculture is one of the largest consumers of freshwater, and excessive withdrawal can lead to water shortage. Sources like Springer Link 2023, UNEP 2020, and Fennec Water 2022 provide evidence on how irrigation and farming activity impact water resources. In addition, the expansion of agriculture irrigated land, intensive water usage, the more land dedicated to irrigation, the more water is needed. Study by Nick Hepon 2023, Ingro 2023, and Al-Sharif 2022 discuss how irrigation practice contribute to freshwater consumption. Finally, overall water usage across different sectors, including domestic, industrial, and agriculture, directly affect renewable freshwater availability. Research by Richard and Van Wesenberg 2020, IPCC 2022, and Telfa et al. 2024 emphasize the need for sustainable water management to prevent depletion. Next, I will be presenting of our research which focus on the theoretical framework for renewable freshwater. Our study aimed to examine the key factors that influence the availability of renewable freshwater resources using relevant data sources and theoretical perspective. Our dependent variable in this study is renewable freshwater resources, which we measure in cubic meter per year. The data for these come from the reliable sources like the World Bank and FAO Aquastat. The first independent variable is population growth. We measure this through the annual population growth rate using data from the World Bank and the United Nations Population Division. Next, we consider rising temperature. We measure this using the annual average temperature data from the World Bank Climate Data, NOAA, and the emission database for global atmospheric research. Agriculture water withdrawal refers to the percentage of total water use allocated to agriculture, since agriculture is a major consumer of fresh water. This variable plays a critical role in our study. The data is sources from FAO Aquastat, National Agriculture Database, and Our World in Data. Another key factor is agriculture irrigated land, which measures the percentage of total agriculture land that relies on irrigation. Our data come from the World Bank and the FAO land use data. Finally, water usage is analyzed by measuring total water use in relation to GDP using data from FAO, Aquastat, and National Statistics. In summary, our theoretical framework examines how renewable freshwater availability is influenced by population growth, rising temperature, agriculture water withdrawal, water use, and agriculture irrigation land.
Assalamualaikum. My name is Warjina Nabila, and next I will present about the chapter 4 data analysis. First, we start with the unit root test. There is 3 tests under this unit root test. First is LLC test, second is IPS test, and third one is Hadri test. For the LLC test and IPS test, the data series at second different are stationary as all of the variable, which is p-value are less than 0.1, reject the null hypothesis. Meanwhile, data series at level and first different are non-stationary at most variable where p-value is more than 0.1, fail to reject the null hypothesis. While for the Hadri test, the data series at level, first different and second difference are non-stationary at most variable where p-value is more than 0.1, fail to reject the null hypothesis. So it can be concluded that out of 3 tests, the data series are stationary using the LLC test and IPS test at the second difference. So next, the second test we use is multiple linear regression model, which show a Jacobi normality test, which show p-value at 0.1713, and the W Watson statistics show the p-value at 0.0922. The third is diagnostic checking of flat TV model. We use this Darwin-Watson autocorrelation test, which show the p-value is at 1.8378. And fourth one is multiple linear regression result of model 4, which is all the independent variables show an insignificant relationship with the dependent variable, except for the rising temperature. It shows a significant relationship with the dependent variable, which is renewable freshwater. Next, we move on to the short run and long run result, which is we use the ARDL test. So first one is population growth. It shows an insignificant negative impact in short run and insignificant positive impact in the long run. For the rising temperature, it shows an insignificant negative impact in the both short run and long run. For agriculture irrigated land, it shows insignificant positive effect for both long run and short run. For agriculture water withdrawal, it shows insignificant negative effect for both short run and long run, while for the water usage, it shows that insignificant positive effect for the long run and short run.
There are 5 of implications of this study. The first implication is decision-making impact. Provides insight for policymakers, governments, investors, and also researchers. It will help assess whether renewable freshwater affects the water scarcity in Jordan, Yemen, Iraq, Lebanon, and also Syria from 2000 to 2023. Second implication is unexpected findings. No significant correlation found between renewable freshwater and the 5 independent variables, which is the first one is rising temperature, second is population growth, third IV is agricultural irrigated land, fourth is agricultural water withdrawals, and the last IV is water usage. Panel regression result shows all variables had a negative but statistically insignificant effect. The third implication is theoretical implication. Usually question existing assumption about water scarcity drivers. It suggests other unexamined factors may have a stronger influence. Calls for re-evaluating theoretical frameworks in water resource management. Other than that is research implication. Future studies should explore more additional variables beyond this analysis. Use advanced methodologies such as panel data models, machine learning, and also qualitative approaches. Combine economic, environmental, and also governance factors for deeper insights. The last implication for this study is practical implication. Traditional water scarcity assumption may not fully explain this issue. So, government should re-evaluate policies and implement more alternative solutions. Encourages regional cooperation for effective water sharing agreements. This study actually explored on how renewable freshwater availability is influenced by factors such as population growth, rising temperature, agricultural water withdrawals, agricultural irrigated land, and water usage in Jordan, Yemen, Iraq, Lebanon, and also Syria. The results showed that rising temperature significantly reduced the renewable freshwater, while other factors had no statistically significant impact. This suggests that climate change actually is a major driver of water scarcity in the Middle East countries, while other expected influences such as population growth and also agricultural maybe can manage through governance and also technological advancement. Actually, to improve understanding of water scarcity, future studies should include more countries to analyze longer time periods and consider policy and governance factor. Actually, advanced statistical methods such as machine learning and also panel data models could also enhance more accuracy in this study. There are a few recommendations for future research. The first recommendation is expand the study scope. Include more countries beyond Yemen, Jordan, Iraq, Lebanon, and also Syria. Extend the study period from 10 years to 20 years for a better trend analysis. Larger data sets actually can improve more accuracy and also reliability of findings. The second recommendation is enhance data collection and monitoring. For future research, maybe they can implement robust groundwater monitoring system and also improve the real-time water usage tracking for accurate data. And then also for future research, they can strengthen regional collaboration for standardized data. The third recommendation is explore additional variables and models. Future researchers can investigate new explanatory variables affecting the water scarcity. Might be in the future research, they can use advanced econometric and also machine learning models for better prediction. And also they can integrate climate projection to analyze long-term water availability. The last recommendation is analyze policy and also institutional factors. Might be they can conduct qualitative research on water policies and also governance structures. In future research, they may assess effectiveness of water sharing agreements in managing scarcity. Actually, develop a policy recommendation for sustainability water management is actually a good idea.